All right, so we're taking a look at last year's benchmark 2. So people that took algebra 2, this is a practice, or it might have been the actual test that they took. All right, the people that were in your seat last year, this is what they did. All right, so we'll take a look at these. First one we're going to take a look at, guys, this is just putting pencil to paper. We are doing the non-calculator section. So those of you that have your calculator, we won't need those today. We're completely doing the non-calculator section. Remember this, we are distributing a -2 here. They're counting on somebody not doing the -2. There's multiple choice answers that match this. All right, I'll show you what I mean. Let's say I did not distribute the -2 to both terms. I just distributed it to the 6 and left the 3 alone. They are kind enough to have the incorrect answer for you. So make sure you take your time. A lot of times, and this is also true on your ACT, when stuff seems simple, okay, take your time. A lot of times we get on something simple, it's like, well, I'm gonna make up some time on the ACT. No, take your time and make sure you get these. Blake, you play basketball. It's a layup, right? The way we miss layups is you don't give them the respect and you hustle. Just lay it up. Take it easy. Focus. Don't stress about it, but also take your time. Make sure we do this right. So I distribute in my -2, and then we have 4 minus 9i. So we have -8, and then this is -15i. Guys, you will not have the calculator to put this portion in your calculator, things like this, so you have to do these by hand. No problem, all right? No problem there. All right? This question right here. Now, I can do this one at a glance. Make this a little bit bigger here for you so you can see. I can do this at a glance. Can anyone else? Nobody? Sonny, what do you know?
I know that it can't be C because it's an exponential function.
It's C is a quadratic, you meant?
No, the actual graph.
Oh, gotcha. You're on the right track. He's talking about the family of functions, which is how I know the answer. So he said it's definitely not C. How do you know it's definitely not C? C is a quadratic family. D is a cubic family. You're not real sure about B though, huh?
B, I don't know what it is, but it's not.
It's not that though, right? So let me share with you guys. Great job, Sonny. Good for you. Don't even have to know this stuff. Here's the families of functions. Just a real quick reminder to you. If you have just an x, that is a linear function. Straight line, all right? Up, down, left, right, can go 4 directions, go any direction. Quadratic we are very familiar with. Remember, you can have the parabola. It can be facing upward. It can be facing downward. It could get thinner, shorter, all that good stuff. It can't lay on its side or it's not a function. The cubic function is the family of function that looks like this. It can also be flipped upside down. Look like that. It can be stretched, compressed, shifted, but it's going to look like that. The square root family, which is the one that we have, is going to start at a point and go forever in one direction. It could go backwards, it could go downward, it could go down and leftward, but it's going to have basically a bent ray. And then the cube root, there are more than just these families, but these are going to be the ones we're generally going to see. It's kind of like the cubic function, but it's laying on its side. All right, that's all fine and good. Here's a point that I want to point out to all of you. Everybody take a look at this. If you get in a spot on these and you're not sure what to do, plug in a unique point to that graph. I see a lot of people are not watching. Watch this. Watch this. So 1, 0 is not a unique point on any graph because it shows up on all of those. Agree? A unique point on A would be the point 4, -2, right? So if you were to plug in 4, -2 into your equation, if it goes through a point on the graph and it's a false statement, that's the wrong graph. If it's a true statement, you have the right graph. So we'll practice both of these. So I'm plugging in the number 4 and then -2. So I take the equation. In place of the y value, I'm going to plug in -2. And in place of the x value, I'm going to plug in 4. Whoops. Square root. So that's the function with 2 input values, 4, -2. Why did I pick 4, -2? Why did I pick 4, -2? It's unique to that graph. It's an ordered pair, right? So the square root of 4 is 2. So I end up with -2 times -2. And make sure you follow your order of operation. So what we end up with is, whoops, 2 minus 4, which is in fact -2. So this answer is correct. Now, pick a unique point. Like if I would have picked 1, 0, it would have worked. But it would have worked for C as well. It would have worked for, whichever function as well. Let's pick another just to show you what a wrong answer looks like. Look at B. Do y'all see a point on B that is unique to B? 8, -2 is unique to that particular one. So when I plug in 8 to our equation, which was, so we're plugging in 8, -2. When we plug in -2 our equation, we're going to get a weird number, right? So this is definitely not the right answer. The square root of 8, I don't even know what that is. Is that like 2.4 or something? Somebody mind helping me out with that? Actually, we don't have our calculator, right? This is a non-calculator section. But we know it's an irrational number. And we know that 3 times 3 is 9 and 2 times 2 is 4, right? So this is a number between 2 and 4. So let's just go right in half, even though it's an irrational number, which throws me off here completely. I'm taking this one off the board, but we can clearly see that this does not work. So this B is wrong for that reason. So if you forget the family of functions, don't forget that basic idea that if it goes through a specific point, it should plug in and work for that equation. All right? So our answer is A, which Sonny pointed out by knowing the family of function relationship, which is a much better move. All right? Moving on. Let's take a look at this one. Guys, I want to talk about this in a way. This is just general test taking I want you to think through. I am not happy with you if you choose A or D on this. If you choose A or D, I am not happy with you because you're not even thinking pattern-wise, much less the solution. Let's do it right real quick. Remember, if I have a solution of -4, where did that come from? What factor?
The factor x plus 4.
X plus 4. Where did 3 come from?
-3.
And 8, x minus 8. So we're definitely looking at B. Here's why I have a problem with somebody selecting A. I'm not mad at you if you pick C. I'm a little upset because I think we should know how to do this. I'm mad at you if you pick A or D because you didn't try. Guys, give a good solid effort. All right? Give me a good solid effort. But think about this real quick. The 4 and the 3, are they alike or are they different, the types of numbers that they are? One's negative, one's positive, right? So if you decide incorrectly, let's just say you choose D, and you say, you know what? I think that x equal to -4 comes from x minus 4. Okay, I can live with that. But you're saying you're keeping the same sign, right? Does the 3 have the same sign as the 4? The -4? No. So how could this keep the same sign and then this one be the opposite? Y'all follow what I'm saying there? That doesn't even match up within the answer. Pick answers that make sense in themselves. Why would the 8 be different than the 4 and the 3 be the same thing when they're both the same type of number? Does that make sense? So like C, I'm not too terribly upset at you with C. Because with C, at least it's some consistency. You said, okay, x minus 4, yay. And then I'm going to say x plus 3. Okay, well, that makes sense because they're different signs, so they had different behaviors. And then you said 8 was positive. Okay, I'm not mad at you. I'm disappointed because I think we should know how to answer these. But at least there's consistency in your answer. Don't pick answers that are not even consistent in themselves, okay? Make sure there's some consistency in yourself. You don't have your graphing calculator here, so you cannot graph these and see which ones cross. But remember, they are solutions that are opposite. We'll try to go a little quicker here. Here's another one. I'm not too terribly upset at you on this. If you're missing these, if you're graphing calculator, here's what everybody, write these down if you've got notes. Just as a reminder, remember this. When we have a fractional power, you actually have a root. It's actually a root. The base is the base, goes there. The denominator is what's called the index, which goes there. And the numerator is the power, so we have that. So the 2 would have a root. The base would be 2, the power would be 5, the index would be 5, the power would be 2. That's the rewrite. And some of you are like, yeah, that didn't clear up anything for me, Mr. Castile. Okay, that's all right, but let's just bear with me for a second. You need to memorize this. You need to memorize this. This is how we convert these things. Here's what I want to encourage you to do. I'm not as familiar with square roots. Okay, or roots, that's fine. Ryan, give me a square root that you know. You know for a fact. I put a number in here that you know the answer to. Square root of what? Make it easier on me. Think smaller. He said 64. That's right, but I want to make it easy. Pick an easy one, Ryan. 9. Pick another one, Blake. Another easy one. What's the smallest number that has a perfect root? Technically, it's 1, but we're going to go with 4, all right? All right, so here we go. Here's what my encouragement is to you guys. When you run into math that you are not familiar with, turn it into math that you are familiar with. Now, I think everybody should know that 7 to the 1 power is 7, and 2 to the 2nd power is 4. So we can jump to that part right there. So when we multiply these things, let's say you don't know what to do. You don't know if this becomes 10. You don't know if I add these two. I don't know if I multiply these two. I have no idea. By the way, there's the adding the ones for you. You know, they've got you set up where you can mess up all kinds of ways. So, whoops. So what I'm encouraging you to do is turn the math into something simple that you recognize and see what the appropriate measures are. Here's what I mean. What is the square root of 9? Square root of 4? 3 times 2 is 6. Okay? So, remember this is an understood 2, what do I do with these numbers to make this right? What root gives me 6? What root gives me 6?
13.
Not 13. I'm saying the blank root of something gives me 6. What's the answer? 36. Right? So how do you get a 36 with a 9 and a 4? Do you add them? No. What do you do? Multiplying. So here's what we've learned, because the square root of 36 is 6. Here's what we've learned about roots. By going back to our easy stuff, we can see, okay, when we are multiplying roots, we do not change the index. So this is going to stay the 5th root. And what do we do with the radicands? Numbers underneath. Well, what did we do with the 9 and the 4? to get 36? We multiplied. So what should we do with the 7 and the 4? Multiply. So that would be 28D. So, and this is a good ACT strategy as well. I don't have my calculator here, so we have to do this by hand. If it's something you're unfamiliar with, try to revert it to something that you are. Kind of like with rationals, going back to fractions, right? Going back to fractions to help us get through that. I'm gonna have to go a little, so we're moving forward here. First off, this one I want to talk about one basic idea, and that is this. How do we find the y-intercept of a number? How do we find the y-intercept of a number? Easy, easy, easy. What's the y-intercept for every type of an equation? Where x equals 0. So let's take our equation and plug in 0. So f of 0, so it would be the cube root of 0. Cube root of 0 is 0. 0 minus 3 is 0. So what is our y-intercept? -3, right? Well, that only gets rid of 2 answers. You know what I have to say to that? You're welcome. You had a 25% chance of guessing this right. Now you have a 50% chance just by knowing the y-intercept. So when we take our benchmark, where is the y-intercept? What do you do to get a y-intercept? What do you do to get a y-intercept? Plug in 0. Plug in 0 for x, you will have your y-intercept. That is true for every type of an equation. So we're down to 50-50 here. All right? And then even still, we have to plug these numbers in. This one says if you plug in 9, you're going to get 0. Well, the cube root of 9 is not 3. It is not 3. Remember, cube roots work this way. Here's the two numbers we're deciding between, 27 and 9. Square roots escape in pairs, but this is a cube root, so they escape in sets, which is 3. And 27 does factor down where we have 3 3s, right? So that would be our solution, 27. 27. But again, y-intercept, x equals it to 0, and we got our y-intercept. All right, this is another one as well. Let's talk about a couple of things here. The y-intercept is -7. Look at our instructions here. Which answer is off the board if the y-intercept is -7? Which answer is off the board? Sarah, which one of these does not have a y-intercept of -7? D. So D's off the board, right? You're out of here, D. Sorry. Now let's talk about another easy thing. A negative leading coefficient. Does anybody recall what a negative leading coefficient does? What's it make the graph do? It affects where the graph ends. So if you have a negative, think of it like the stock market. What's a stock that's doing in a negative doing? Going down, kind of like this one, kind of like that one, not like that one. You're out. Sorry, A. Come again. All right, now here's another thing where I'm talking about the pattern. Everybody read the instructions here. It says in the first two, f of x has a 0 with multiplicities of 2 at -5, and then at the next one, f of x has zeros with multiplicities at 2 at x equals 6. Is that the same thing or is that different things? Not the solutions, but the description of the solutions. Is the description of the solutions the same or is it different? Did they describe them the same way? Was x equal to -5 and x equal to 6 described in the same way, Ryan? Skylar's shaking his head, yes. They were described in exactly, verbatim, word for word, right? So think about this real quick. Here's what I'm talking about on patterns. If two things are described in exactly the same way, why would their graphs be different? Why would this one be bouncing and this one be passing through? If they were described in the same way, why would they be doing different things? Right? think things like that as anytime you take any kind of test, anytime you do anything in life, really, pattern recognition is a very useful tool. So we have this. These two at -5 and 6 are doing the same thing, which is what they should do because they were described the same way. Now let's just have a real quick review on what multiplicities are. Remember, your even multiplicities do the bouncing thing. They get to the graph and they bounce. Can come from the top or come from the bottom. Odd multiplicities do the wiggle. They get here, and then where you think they're going to bounce, they actually turn back up. These are odd multiplicities. Whoop, that one's ugly, but you get the idea. But when it comes down to it, guys, make sure you recognize patterns. They're described the same way. They better do the same thing, all right? Because we are talking about solutions, aren't we? Solutions are the x-axis. Moving forward. This question, you can get around this question by doing, guys, put pencil to paper. You guys know how to do this thing. So you know how to do 17 times 27. Stack them, multiply them. Put your pencil to paper and do it, all right? And then do the same thing with the multiple choice answers. May I suggest something? Start with these two because they're the easiest ones. But even still, it's not like you got to start afresh. You're doing 22 squared every time. You're doing 5 squared every time, right? So actually put pencil to paper. I'm going to show you how they wanted to see this one. For those of you that do a little better on this. These two numbers are 10 units apart. Would you all agree? So what's the midpoint of these two? If they're 10 units apart, the midpoint is how far away? 5. So what is 5 units away from 17? 22, right? 22 is the middle. Here's what they wanted you to do on this. 22 minus 5 and 22 plus 5 are our two numbers. Agree? 17 is 22 minus 5. 27 is 22 plus 5. This is the difference of squares. It's conjugates multiplying together. So we do the squared term of the first minus the square term of the second. And that's why we would get D there. But guys, you can put paper to pencil. You can put paper to pencil and figure this out. These are just numbers. They're big numbers, but you can do it. Don't be lazy. It's kind of a lazy doing those. All right, moving forward on this one. I don't want to spend a whole lot of time on this except for just talk about the physics of this thing. It says a contractor wants to estimate how many tiles it will take to cover all the interior walls of a pool. Does the amount of water have anything to do with how many tiles it's going to take? No, that's volume compared to surface area. So in this particular one, it does not depend on the volume, it depends on the surface area. Depends on the surface area, not the volume. And this one. Take a look again at our solutions. This one at least has some consistency. Here's what I mean by that. Like the solutions here are all consistent. Here's what I mean. The 8 looks like the 3, the 8 looks like the 3, the 8 looks like the 3, the 8 looks like the 3. The 6 doesn't look like them in either one of those. Yeah, the 6 doesn't look like them in either one of those. So there's no pattern there. But what you need to recognize is this. Your y-intercept has nothing to do with the factors and nothing to do with the solution. This thing does not belong in this equation. And think about what we have here directionally. Think about our directions. We're going up. There's one direction. We're going down. That's 2 directions. We're going up. That's 3 directions. 3 directions equal 3 powers. Agree? How can we have 4 powers? We have no multiplicities there, no bouncing. You can't have 4 powers unless you have 4 directions or a multiplicity, right? So those two are out. Those two are out. Guys, you do not have your graphing calculator on these, so you can't do it. By the way, on any and all of these answers, what's the y-intercept again? What's the y-intercept? -4, right? So if you were to plug in 0 for all these answers, you better get -4 as a solution. Okay? Plug in 0, you better get -4 as a solution. And I think, what answer did we decide on this one? This one should be B, right? This one should be B. All right, this one. Again, this is one of those guys, you just got to put pencil to paper. No tricks, you know what you're doing. Let's take a look at this. This is like the one we did yesterday. I'm going to choose to do synthetic division. Since x plus 2 is a factor, we have this. Now, I will tell you this. Have y'all noticed all the practices we've done? They've all skipped a power. So when I list these, 5, x to the third. So I got a third power. I got a second power. I do not have a 1 power. You got to hold its place with a 0. You better get in that habit. So we have that. We're going to run this through synthetic division. 5 is -10, is -9, is 18, is 18, is -36, is -26. I'll give you all a second to look at that. But that is synthetic division. Could you have done polynomial long division? Absolutely. There's never a time where you can do synthetic where you could not do polynomial long division. If you do polynomial long division, remember you still have to, regardless of what you choose, you've got to hold the place of the 0 value there. All right, and I am recording these guys, so I'm a little quick, but you can go back and we'll post these. All right, this is another one, pencil to paper. No tricks, pencil to paper. Guys, the quadratic formula, you know this. I go off on questions all the time. This is not one of them. You should be able to know how to do the quadratic formula. All right, the trick with the quadratic formula is, though, you have to have everything to one side. So our 3 is no good being there. We need to move this value over. So we're going to go 2x squared plus 5x plus 4. Okay, now we plug this into the quadratic formula. A value is 2, B value is 5, C value is 4. So I'm going to go quickly on this. Opposite B, plus and minus the square root of B squared minus 4 times A times C. All divided by 2A. All right, so we have -5 plus and minus square root of 25 minus 4 times 4 is 16 times 2 is 32, sorry, over 4. So we get that imaginary solution because the discriminant, by the way, that's the word for that thing underneath the radical, right, is negative. So there is no, it's an irrational solution, so we end up with that. Answer C. I'm happy with having a quadratic formula question on the test. I hope they do, because that is a skill you need to have. You need to be able to know how to do that, all right? Most common mistake is not squaring the b with a parenthesis, so when you plug in a negative number, it doesn't change. That's the most common mistake. The second one is overlooking the negative sign that goes right here. Don't make those two mistakes. Make a different one. No, don't make any mistakes, but definitely be alert for those. And actually, that's it, isn't it? All right, I was looking at the top and it looked like I had 2 more questions, but that is the last one. Anybody have any questions on any of these so far? All right, good. Yes, Skylar pointed something out. Thank you, Skylar. We have the answer right here, but I circled the wrong answer. And here's another thing. I'll pretend like I did it on purpose. I am just as wrong for selecting C there than JT drooling on the paper and not answering anything, right? I'm equally wrong. I'm equally wrong, so take your time and don't miss these, all right?